Okay, express blah 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 in terms of sine and cosine and write in simplest form. This is good advice when you're doing any kind of trig manipulation. It's very, very often helpful to turn everything into sines and cosines and then see what you can combine or cancel. So 2 tangent A, we know tangent is sine over cosine, so this upstairs part is going to be 2 sine A over cosine A. That's our numerator. And downstairs, well, we could split this up, but do you see another option here that we could do first? 1 plus tan squared is one of our Pythagorean identities. And it's fine if you don't have them memorized, but you should at least recognize when you've got a squared trig function, you should be thinking maybe Pythagorean identity. If you see a squared function and a 1, you should be really thinking Pythagorean identity, because there's quite a few of them that have that combination. 1 plus tan squared A, it turns out, is equivalent to secant squared A. That helps us because it's going to save us some common denominator work we might otherwise have had to do. So there we are, we're all sine, cosine, and now this secant is a problem. Let's see if we can make that look better. We'll leave the top alone, 2 sine A over cosine A for now. Downstairs, what does secant mean? It's 1 over cosine A. So secant squared is 1 over cosine squared A. This is good because now we have nothing but sines and cosines. It's bad because it's a 4-level fraction, and those are kind of awful to work with, but they're not too hard to clean up. If we want to rewrite this more simply, we can say it's the top fraction times the reciprocal of the bottom fraction. Right? Multiply and flip. So you get 2 sine A over cosine A. No change there. Times, and now we flip the bottom one and we get cosine squared A over 1. Okay, that's good. We're down from 4 levels to 2, which is a big help. And now you can see we can cancel a cosine here, cancel one of those cosines, and we get 2 sine A cosine A. Now, there's an identity which I don't believe you've seen it yet, which allows you to write this as the sine of 2a. But if you notice that, terrific, good for you. If you didn't, not a big deal. I believe this is where they expected us to stop. It's in terms of sine and cosine, and it's about as simple as we can make it because it's not a fraction anymore.